Hello everyone and welcome to this lecture video on graphing. Graphing is a skill that we will need a lot of this year. So this week we'll get some practice and we'll be using Google Sheets. So looking at this information given in the data table on this screen, we have reaction and braking distances versus speed. So we have original speed, reaction distance, braking distance, and total distance. So reaction distance is the amount that you drive, so how far you drive before your brain thinks, oh no, I need to press the brake. So there's a period of time before you press the brake, and that distance is called your reaction distance. And then your braking distance is how far your car travels while you're pressing the brake. So you don't stop immediately, right? There's some distance there. So this table is giving us information about braking depending on your original speed. But tables aren't always the best way to look at data. It's a good way to organize collected data, but oftentimes graphing allows us to see relationships in the data. So here we have our graph of all three relationships. So we see that the reaction distance, braking distance, and total distance are dependent on the speed that you're going. So that means that speed is the independent variable. It's not it is manipulated, and that affects the distance. So speed is the independent variable on the x-axis, always independent on the x, and then dependent, right? The stopping distance depends on the speed. That's your dependent variable on the vertical axis or the y-axis. Look carefully. At the name of this graph, we have distance versus speed. That's our dependent variable. Versus the independent variable, or y versus x. So we always label or title our graphs in this way. Where we have dependent distance versus independent speed. So we don't say the graph title is the reaction distance depending on how fast a car is going. It should be very simple, y versus x. So that's called the title of the graph. I would also like you to note the axis titles. We have our vertical axis and our horizontal. And when you label your axes, you need to include the variable distance in the units of meters. Same with the x-axis, speed, which is measured in meters per second. So this slide just gives a more formal definition of dependent and independent variables. The independent variable is a variable that is manipulated or changed in an experiment, which lies on the x-axis or the horizontal axis. Ooh, I'm still in highlighter mode there. While the dependent variable is a response to the independent variable, always on the y-axis, which is the vertical axis. When we read a graph, there are a couple things to take into account. The first being the slope, or m, if you're familiar with the equation of a line, y equals mx plus b. So slope, rate of change. We'll look at the y-intercept, where the line or curve crosses the y-axis. So if here's a graph, and we we can just stick with the speed. And distance in meters. If our line looks something like this, we would have a slope calculated by rise over run, m, and a y-intercept, the place where the line crosses the x-axis. Excuse me, the y-axis, where x equals 0. Okay, and then finally, we have the r-squared value. And this is a coefficient which you can get from Google Sheets or Excel, and it tells you how linear your data is, how well it fits a line of best fit. So if your r-squared value is greater than 0.95, you say for sure this is a linear relationship. If it's between 0.9 and 0.95, you say maybe that's a linear relationship. And if it is below 0.9, we'd say this is not a linear relationship. Okay, so we talk about a couple different kinds of relationships in graphing. The first being a direct relationship. So the x and y axis are both increasing at a constant rate. So notice how this line is a straight line. So the straight line with a positive slope. Means the two variables are changing at a constant rate. Again, the equation of a line, y equals mx plus b, where m has to be positive for a direct relationship. Next, we have an indirect relationship. And this is when either the x-axis increases and the y-axis decreases at a constant rate. Again, a constant rate means straight line. Or the x-axis decreases while the y-axis increases. So this is an indirect relationship. It's a straight line with a negative slope. So notice how this slope is pointing left. This is a negative slope. So it's still the equation of a line, y equals mx plus b, but this time our slope is negative. So we have two linear relationships. We can be direct or we can be indirect. However, our graph will not always look like a line. Sometimes we might have an inverse relationship. So as one axis increases, the other decreases at a varying rate. So this is what's different. Linear relationships, everything changes at a constant rate. Now we have a varying rate. So our graph curves, and we do not have a line. Inverse relationships are given by y equals m over x, where m is the varying slope. So please note the difference between indirect and inverse relationships. Finally, we have the quadratic relationship. As the x-axis increases, y increases at a parabolic rate. So note that quadratics match the equation y equals mx squared plus b, and their graphs are curved or they make a parabola. Finally, we'll discuss reading a graph with interpolation or extrapolation. So interpolation is reading a graph between the data points. So when a graph that when you're looking at it, you can kind of estimate the value to interpolate, or extrapolate, which is outside of the range of data. So if we wanted to interpolate right now, we wanted to know the value, let's say between data points. So how about 4.5? So when x equals 4.5, we interpolate to find y. So we can do so with the equation of the line, or this graph allows us to estimate. So we go to 4.5, we go up, and then we can look over on our y-axis. That looks like we're at about 13. We can also extrapolate and that would be if we wanted to know what y was equal to when x is outside of our data range. So let's say when x is equal to 13. See how our x values only go to 10? So this is outside of a range of data. We extrapolate. First, we need to write the equation of this direct relationship. Y equals mx plus b. M is the slope, rise over run. So we'll do the slope of the whole graph. So our rise starts at 0 and goes to 30. 30, our run, we started at 0 and went to 10. Our slope is 3. So we go up 3 blocks for over every 1. Okay, and then B, the y-intercept, where our line crosses the y-axis, that is at 0, or at the origin. So we write our equation, y equals 3x plus 0. We want to extrapolate and know y when x is equal to 13. So y equals 3 times 13, which is equal to 39.